We stand at the cusp of a biological revolution. It's a revolution as profound as the discovery of fire or the invention of the wheel. This is the era of biotechnology, where the stuff of science fiction bleeds into our everyday reality. We are no longer passive observers of the biological world. We are becoming active participants, wielding the tools to reshape life itself. For centuries, we have marveled at the intricate machinery of cells and the elegant dance of DNA. We have sought to understand the language of life, to decipher the code that dictates form and function. Now, armed with this knowledge, we are beginning to rewrite the script. We are editing genes, engineering organisms, and blurring the lines between biology and technology. This newfound power fills us with both exhilaration and trepidation. The potential benefits of biotechnology are staggering. We can envision a future where diseases are eradicated, where hunger is a distant memory, and where human potential is unleashed in ways we can scarcely imagine. But the path forward is not without its perils. As we venture into this uncharted territory, we must proceed with caution, guided by wisdom and a deep respect for the sanctity of life. Imagine a world where parents can select the traits of their children with the precision of ordering a customized latte. This isn't just a scene from a science fiction movie, it's a potential future that is rapidly approaching. Want your child to be tall, athletic, and musically gifted? Perhaps you envision a future where your offspring excels in academics or possesses an artistic flair. No problem, just tick the appropriate boxes on the genetic order form. This form could become as commonplace as a birth certificate, detailing the genetic enhancements chosen for your child. This is the seductive yet unsettling promise of designer babies. The allure of creating a perfect child is strong, but it comes with significant moral and ethical dilemmas. With the advent of powerful gene editing tools like CRISPR, the ability to manipulate the human germline, the DNA passed down from generation to generation, is no longer a distant fantasy. It is a technology that is already being tested and refined in laboratories around the world. It is a looming reality. The implications of this technology are vast and far-reaching, touching every aspect of human life and society. The potential benefits of such technology are undeniable. Imagine a world where genetic diseases like cystic fibrosis, Huntington's disease, and sickle cell anemia are eradicated. We could potentially eliminate inherited diseases, ensuring that future generations are spared the suffering caused by genetic disorders. This could lead to a healthier, more robust population. But the ethical implications are profound, raising a host of complex questions. The power to alter human genetics brings with it a responsibility that we are only beginning to understand. What constitutes a desirable trait? Is it intelligence, physical strength, or perhaps creativity? These are subjective qualities that vary greatly across cultures and societies. Who decides what constitutes a life worth living? This question is not just philosophical, but deeply personal and societal. The decisions made today could shape the future of humanity in ways we cannot yet predict. Will this technology exacerbate existing inequalities, creating a genetic elite and leaving others behind? The potential for a new form of social stratification based on genetic enhancements is a real concern. The prospect of designer babies also forces us to confront fundamental questions about human nature. Are we defined solely by our genetic makeup, or is there more to our identity? Is our individuality simply the product of our genes? Or do our experiences, environment, and choices play an equally significant role in shaping who we are? Or is there something more, something intangible, that shapes who we are? This intangible essence could be our spirit, our consciousness, or the sum of our experiences. As we tinker with the very essence of what it means to be human, we must tread carefully, ensuring that our pursuit of progress does not erode the very values that make us human. The balance between innovation and ethics will be crucial in navigating this brave new world. Cancer, the emperor of all maladies, has plagued humanity for millennia. Its presence has been a shadow over human history, causing untold suffering and loss. From ancient times to the modern era, the battle against cancer has been relentless. Its relentless assault on our bodies has instilled fear and inspired countless quests for a cure. Scientists and doctors have dedicated their lives to understanding and combating this disease, driven by the hope of finding a definitive solution. Now, with the rise of precision medicine, we are finally beginning to turn the tide against this formidable foe. Precision medicine represents a paradigm shift in how we approach cancer treatment, offering new hope and possibilities. Traditional cancer treatments, such as chemotherapy and radiation, are often compared to carpet bombing. They damage both cancerous and healthy cells, leading to debilitating side effects. These treatments, while sometimes effective, can leave patients weakened and vulnerable. Precision medicine, on the other hand, is like a guided missile, targeting cancer cells with pinpoint accuracy while sparing healthy tissue. This approach minimizes the collateral damage and focuses the therapeutic effects where they are needed most. This targeted approach is possible thanks to our growing understanding of the molecular underpinnings of cancer. Advances in genomics and molecular biology have unveiled the intricate details of how cancer develops and progresses. We are learning that cancer is not a single disease, but rather a constellation of diseases, each with its own unique genetic and molecular signature. This diversity means that each type of cancer requires a tailored approach for effective treatment. By identifying these specific vulnerabilities, we can develop therapies that exploit them, delivering a lethal blow to cancer cells while minimizing collateral damage. This precision allows for more effective and less harmful treatments. Imagine a world where cancer is no longer a death sentence, but a manageable chronic condition like diabetes or heart disease. With ongoing treatment and monitoring, patients could live full, productive lives despite their diagnosis. This is the promise of precision medicine. It offers a future where cancer can be controlled and managed, reducing the fear and uncertainty that currently surrounds the disease. The development of targeted cancer therapies is a testament to the power of scientific collaboration. Researchers from around the world are pooling their knowledge and resources to make breakthroughs that were once thought impossible. Researchers from diverse fields, genetics, oncology, immunology, computer science, are coming together to unravel the complexities of cancer and develop innovative treatments. This interdisciplinary approach is crucial for tackling the multifaceted nature of cancer. This collaborative spirit, fueled by a shared sense of urgency and purpose, is essential if we are to truly conquer this devastating disease. By working together, we can accelerate the pace of discovery and bring new treatments to patients faster than ever before. Patients are already benefiting from these advancements. Personalized cancer treatments are becoming more common, offering hope to those who previously had limited options. Each patient's treatment plan is tailored to their specific genetic makeup and the characteristics of their cancer. The future of cancer treatment is bright with the promise of precision medicine. As our understanding of cancer continues to grow, so too will our ability to fight it. The journey is far from over, but the progress we have made is a testament to human ingenuity and determination. For patients and their families, this progress brings hope. Hope that one day, cancer will be a thing of the past. Hope that future generations will not have to endure the same struggles. And hope that together, we can overcome one of the greatest challenges of our time. The fight against cancer is a collective effort, involving scientists, doctors, patients, and advocates. Each plays a vital role in advancing our understanding and treatment of this disease. Through continued collaboration and innovation, we can look forward to a future where cancer is no longer a formidable foe, but a conquerable challenge. Section 4. The enemy of my enemy is my medicine, harnessing viruses and bacteria for good. Viruses and bacteria, those microscopic agents of disease, have long been viewed with fear and loathing. They are the invisible enemies that have plagued humanity throughout history, responsible for countless epidemics and pandemics. But in a surprising twist, these very same microbes are now being harnessed as powerful tools in the fight against disease. It's a classic case of the enemy of my enemy is my friend. One of the most promising applications of this approach is the use of viruses to deliver therapeutic genes to cells. These engineered viruses, stripped of their disease-causing capabilities, act like molecular couriers, ferrying genetic payloads to specific targets within the body. This technology holds immense potential for treating a wide range of genetic diseases, from cystic fibrosis to muscular dystrophy. Bacteria, too, are proving to be valuable allies in the fight against disease. For example, researchers are engineering bacteria to produce life-saving drugs and vaccines within the body, creating tiny biological factories that can deliver treatments directly to the site of infection. In the future, we may even be able to program bacteria to seek out and destroy cancer cells, acting like microscopic assassins on a mission to eradicate disease. Section 5. Fueling the Future. Biotechnology and the Quest for Sustainable Energy. The world is facing an unprecedented energy crisis. Our current energy consumption patterns are depleting fossil fuel reserves at an alarming rate, and the environmental consequences are becoming increasingly severe. Our reliance on fossil fuels is unsustainable, contributing to climate change, air pollution, and geopolitical instability. The burning of these fuels releases harmful pollutants into the atmosphere, exacerbating global warming and causing health problems for millions of people. We desperately need alternative sources of energy, and biotechnology is poised to play a pivotal role in this transition. By harnessing the power of living organisms, we can develop innovative solutions that are both efficient and environmentally friendly. One of the most promising areas of research is the development of biofuels. These fuels are derived from biological materials and offer a renewable alternative to traditional fossil fuels. Unlike fossil fuels, which are derived from ancient organic matter, biofuels are produced from renewable sources, such as plants and algae. This means they can be replenished more quickly and sustainably. These biofuels can be used to power vehicles, heat homes, and generate electricity, all while reducing our carbon footprint. By replacing fossil fuels with biofuels, we can significantly cut down on greenhouse gas emissions. Scientists are exploring a variety of approaches to biofuel production. Each method offers unique advantages and challenges, and ongoing research is crucial to optimizing these processes. Some are genetically engineering algae to produce lipids, which can be converted into biodiesel. This approach leverages the natural oil-producing capabilities of algae, making it a highly efficient method of biofuel production. Others are developing enzymes that can break down plant cellulose into sugars, which can then be fermented into ethanol. This process utilizes plant waste materials, making it a sustainable and cost-effective option. Still others are exploring the use of bacteria to produce hydrogen gas, a clean-burning fuel that produces only water as a byproduct. Hydrogen fuel cells have the potential to revolutionize the energy sector by providing a zero-emission alternative. The transition to a sustainable energy future will require a multifaceted approach, combining advances in biotechnology with innovations in solar, wind, and other renewable energy technologies. By integrating these diverse energy sources, we can create a more resilient and sustainable energy infrastructure. By embracing these technologies and investing in research and development, we can create a cleaner, healthier, and more sustainable future for generations to come. The quest for sustainable energy is not just a scientific challenge, but a moral imperative, demanding our collective effort and commitment.